Get your review sheets out. Review sheet out. We're going to go over the review sheet today. Well, half the review sheet. We're going over half the review sheet today, half of it tomorrow. I know some of y'all are going to be gone for track and field. We'll talk about it in a minute. But problems 1 through 5, we want to evaluate this. Evaluate each expression for x equals -2 and x equals 3. Well, we can start off with number 16, or number 1. 16 to the x minus 5. So we'll start off with -2. Yep. Welcome. So the first thing we're going to start off with 16 to the -2 plus 5. Now we could simplify -2 plus 5 if we wanted to, or we can leave it as 16 to the -2 plus 5. Now at this point here, we could grab either calculator and say 16 to the -2 plus 5 is 4,096. That's it. We evaluate it for when x is -2. Questions on number 1 for when x is -2. We also want to evaluate it when x is 3. So we have 16 to the 3 plus 5. And again, you grab the calculator, type it in. 16 to the 3 plus 5 is 4,294,967,296. Yep. But again, all that is you type it in the calculator, let it do it for you. 4294967296. 4294967296. And likely, yes. I mean, it is a big number, but likely you'll have it right there on the calculator. Just write it out. Because really we have 16 to the 8th. You're multiplying 16 by itself 8 times. Questions on number 1? Any other questions about number 1? We can look at one more. 2, 3, 4, 5. Which other one do y'all want to look at? 3. 2 to the 5x minus 2 to the x. Well, the first value of x is what? -2. So we have 2 to the 5 times -2 minus 2 to the -2. So we plug -2 in for x. Yes? Questions on this so far? So now I'm going to grab the calculator and say 2 to the 5 times -2 minus 2 to the -2. So we typed in exactly as it looked, and then we're going to hit enter. -0.249. That's it for -2. Questions on this here before we look at when x is 3? So when x is 3, we'd have 2 to the 5 times 3 minus 2 to the 3rd. Again, I'd grab the calculator, say 2 to the 5 times 3 minus 2 to the 3rd. It's 32,760. Questions on 1 through 5? We feel good with 1 through 5. Okay. I will tell you this here. There are 6 problems on the test that are 1 through 5. Evaluate these exponential expressions. 6 of them. 6 of them for part 1. 6 through 11, not going to be on the test. Next one we're looking at are these here. Rewrite each logarithm, rewrite each equation in exponential form. We're going from logarithmic to exponential. Logarithmic to exponential. Log base b of x equals y if and only if b to the y is equal to x. If and only if. Just an arrow with to it saying that we can go from one to the other. Log base b of y equals x is true if and only if b to the y equals x. If one's true, the other has to be true. So if we look at the first one, log base 9 of 6,561 equals 4. We want to rewrite that as an exponential. What is our base for this here? 9. So that's our b. So b to the y. Well, y in our case is what? 4. So b to the y would be 9 to the is equal to x. Well, x is 6,561. That's it. The nice part with these here is, well, you can type 9 to the 4th on the calculator, and it will tell you it is indeed 6,561. Questions on 12? Let's look at 13. Log base 5 of 78,125 equals 7. So what would this be? 5 to the 7th equals 78,125. That's it. You know what? While we're at it, why don't we go and do the next two? Log base 1/7 of 2,401 equals -4. -4 is equal to. We can put parentheses around the 1/7, but 1/7 to the -4 is equal to 2,401. I think it's kind of funny. 15 is log base 15 of 15 equals 1. So as an exponential, it would be what? 15 to the first is equal to 15. I would put that first power because it is understood that 15 to the first is the same as 15. So first power is understood, but go on and write it because, again, exponential, we're wanting to see that. Questions on these first 15, or these first 4? Be good with these here. Yes? All right, let's look at the next 16 through 19. The natural log of x equals y if and only if e to the y is equal to x. Natural logs, the base is understood to be e. So with natural logs, we don't have to write the base because it's understood. So the natural log of x equals 7. If we rewrote this as an exponential, well, the base is e, and it would be to the 7th is equal to and that's it. The natural log of 6 equals y would be what? E to the y is equal to 6. Natural log of 71 equals y would be what? E to the y equals 71. Because again, it's not so much what the numbers or terms are, Natural log of this equals this. E, what is it equal to? Equals that. So even if it was the natural log of 71 equals, or natural log of x equals e to the e equals x, we can have e to the e. Again, same process. Natural log of x equals 9, so e to the 9th equals. Questions on these here? So are we good with 12 through 19? 8. There's 8 of these on the test. 8 of these on part 1. We ready for 20 through 25? Rewrite each exponential as a logarithm. So we're going back the other direction. I'll tell you this now. There are 8 of these on the test. So b to the y equals x if and only if log base b of x is equal to y. You can rewrite that. That is the same statement we just had before. I just have it flipped. So 3 to the 4th equals 81. Log base what? I heard it. 3 of equals. We're just going back the other direction. Questions on 20? Questions on how we got the 3, 81, and 4? You see where they're going, where they're coming from. So what about 21? It would be what? Log base 1 over 5 of 1 over 125 is equal to 3. Okay. 22, log base what? 125 of 25 equals 2/3, 2 over 3. That's it. Let me put the other one there for natural logs. E to the y equals x if and only if the natural log of x is equal to y. So for 23, e to the 4th equals x. We would rewrite it as natural log of x is equal to 4. Initial log. Yeah. I mean, it makes more sense because, again, natural log feels like it should be in L, not LN. I still don't know why they flipped it. E to the y equals 27. Natural log of 27 is equal to y. Yeah. Natural log of 27 equals y. 25, e to the y equals x. Almost. Natural log of y equals x. Yep. But again, that's 8 of the problems on part 1. Actually, that is exactly half of part 1. So there are 32 questions on the first part. 8 of the 32 is to rewrite from logarithmic to exponential. 8 is to rewrite from exponential to logarithmic. So that's 16 of the 32. That's half the test. 6 of them are also just the evaluating the logarithmic expression. So calculator, yes? The next 6 questions. Evaluate each logarithm in around 3 places. So that, again, 6 more. Our calculator, plug it in. Now we could use the change of base for these logs, LOGs, or we can use the graphing calculator. Figure both of those out. Now again, to get natural or log base, on the graphing calculator, we're going to hit math. Scroll up or down to find log base, and then type it in. Well, I'm going to need the review sheet back. Because the first one we're looking at is log base 5 of 1 over 125. And again, fractions are alpha, y equals, enter. So, yeah, we'll do that here again. So questions on 26, we'll do the same thing with 27 and 28. So 27. So math, scroll up or down, it doesn't matter which. We're looking for log base. Now this next one is log base 9 of 2,187. 9, 2,187 is 3.5. Alpha, y equals, enter. Huh? Yeah, we can just type it in. Yep. Questions on 26 or 27? We ready for 28? Now 28, there's two ways we could type it in. One is we go log base 10 0.1, 2, 3, 4, 1 and get -5. Now our common logs, log, if the base is not written, it's understood to be what? 10, yes? What's the base of this one here? 10. So I could have also said log 0.1, 2, 3, 4. And got the same thing. Because since the base is understood to be 10, our log button, since it is base 10, we can hit it and do it instead. Because the base is understood to be 10. If the base is not written, it's understood to be 10, we can just use the log button on these here. That's so questions on 26, 27, or 28? We ready for 29? Well, 29, natural log of 27. Well, the base is understood to be what? E. Natural log's E, yes? Well, the nice thing with natural logs, doesn't matter, yeah, we can plug it in, doesn't matter which calculator, because natural log on both is the same. We can just hit the natural log button and do that there. Log for the 30xs, the yellow calculator, has to be base 10. Unless because the only way we can do that is with our change of base. 3.295836866. We'll round to 3 decimal places, 3.296. Wrong spot. If for some reason you're unsure on the rounding, give me the whole decimal. Questions on 29? We ready to look at 30? Log of 2/7, or natural log of 2/7. Natural log 2/7. Negative 1.252762968, or negative 1.253. Now, a log, natural log or log, can equal a negative. That's fine. We cannot have a negative inside of the logarithm. The natural log of 2/7 equals this negative 1.253 is fine. I cannot take the natural log of negative 1.253. That negative cannot be inside the log. They can equal a negative. It cannot be negative or 0 inside. Okay? We're ready for 31. Yes? The natural log of 4 to the 6. I'm not going to have to evaluate 4 to the 6. I can just say natural log of 4 to the 6 is 8.3177 or 8.318. And there are 6 problems like this here on the test. Questions on any of this so far? That is 28 out of the 32 problems on the first part. Be ready to look at the last 4 on parts. So 32 problems on the first part of the test. Yeah, you're good. 28 of them we've covered so far. 2 of the last 4 problems that are going to be types of problems on the first part of the test, 2 of them are going to be expanding the logarithm. Expanding these. Now, expanding comes in 3 main steps. First is the quotient. Our log base b of m divided by n is equal to log base b of m minus log base b of n. 2 is our product. Log base b of m times n is equal to log base b of m plus log base b of n. And our last step is our power property. Our log base b of m to the n is equal to n times log base b of m. Quotient, product, power. Would you like everything that's written on the whiteboard to stay up there this week? Okay, I'll leave it up there. So it'd be good to have it in your notes, but it'll also be up here too. Okay. Product, quotient, power, I just didn't put them together. Now, when we look at the first one, 32, log of 6x cubed y squared. We start off with quotient. Is there something being divided inside the log? No, so we don't have to do the quotient step. We just go straight to product. Our product says if we have 2 or more things being multiplied inside the log, we can rewrite it as a sum of those logs. So we'd have log of 6 plus log of x cubed plus log of y squared. Log of 6 plus log of x to the third plus log of y squared. Now, some programs and some would want us to simplify the log of 6 because 6 is the same as 2 times 3. So really we could say log of 2 plus log of 3. Log of 6 is fine. We don't have to take it that far. Questions on product before we move on to power? Power says we take the exponent and move it to the front. So the 3 is going to be moved in front of its log. The 2 for log of y squared. So we still have log of 6. Plus, we move the 3 out, telling us that we have 3 log of x. Plus, we move the 2 out front, telling us that we have 2 log of y. And that's it. Questions on 32? We ready for 33? Now, one thing, you can put it down as a hint or as a reminder to yourself. When we're expanding, if we have terms in the bottom of the fraction, their logs are going to be negative. So when we get finished, the log connected with y and the log connected with z should be minus that log with y minus the log with z. Because what's on bottom is going to be negative. So let's start off with the first step. Quotient. We do have a quotient. We have two things being divided. So when we simplify or expand it, it's going to be log of the top minus log of the bottom. Log of the top minus log of the bottom. Log of the top minus log of the bottom. Questions on step 1? Let's look at step 2. Product. Log of 7x squared is going to be log of 7 plus log of x squared minus our second one, log of y cubed z squared, is a product. And it would be log of y cubed plus log of z squared. Because if we just had log of y cubed z squared, it would be log of y cubed plus log of z squared. But they're both in the bottom of the fraction. They're both a part of that quotient. That negative has to go to both terms, telling us that we have log of 7 plus log of x squared minus our log of y cubed minus our log of z squared. That negative has to be with both. So I just have a reminder yourself, if it starts off in that bottom of the fraction with expanding, each log term that was in the bottom use that negative. So since z and y were both in the bottom, we need minus log of y minus log of z. Those are both going to be negative because they were in the bottom of the fraction to start with. Does that make sense? And it's good to just have that reminder to make sure we do have that negative, because most likely if you do forget it, I believe normally it's going to be that log of y is going to have the negative. The log of z is the one that's going to miss it if we don't watch it. And then we do our powers. We move the exponent to the front of its corresponding logs, telling us that we have log of 7 plus 2 log of x minus 3 log of y minus 2 log of z. And that's it. Questions with this here? I have a feeling we want to look at 34 and 35, yes? Properties of the natural logs are the same as the logs. Properties of natural logs are going to be the same as the logs. Yes. 3 ln y minus 2 log z. And you put parentheses around if you want. Yep, that's it. So the natural log of 7x cubed over 16y squared. Well, again, we go through the same steps as what we did for logs, log. We have something being divided, so we take the natural log of the top and subtract from it the natural log of the bottom. Natural log of the top minus the natural log of the bottom. So the natural log of 7x cubed minus 16y squared. Questions on our quotient step? All right. 7x cubed is a product, so we'd have the natural log of 7 plus the natural log of x to the third minus natural log of 16y squared would be the natural log of 16 plus the natural log of y squared. Now, if we want to just write minus the natural log of 16 minus the natural log of y squared, that works too, because they will both be negative. Because really, after the product step is complete, we have the natural log of 7 plus the natural log of x to the third minus the natural log of 16 minus the natural log of y squared. Now, I'm not asking you to take the natural log of 16 any further than this here. That works, that's fine. Because really, if we wanted to fully simplify it, 16, we'd see what number to the a power of 16, well, 2 to the fourth is 16. So we'd rewrite it as 2 to the fourth and do the power property. With it, natural log of 16 is fine. Now our power, two places where we have an exponent that we can move to the front. Natural log of 7 stays the same, but our natural log of x to the third becomes 3 natural log of x minus the natural log of 16 minus 2 natural log of. So even though it's natural logs, it's going to behave the exact same way as our logs. Because natural log is the same as log, its base is just understood to be e. Questions on 34? While we're at it, we have some time. We can go on and do 35, natural log of x, or not x, natural log of 8x to the third, y to the second, z to the fourth. There is no quotient. We can go straight to quotient, or sorry, straight to power product. We have our sum. Yeah. And then move to powers. Natural log of 8 plus 3 natural log of x plus 2 natural log of y plus 4 natural log of z. And I mean, just like with the natural log of 16, the natural log of 8, we could simplify 8 to 2 to the third and simplify it that way, but we'll leave it as natural log of 8. Don't have to simplify it any further than that. Questions on this here? We're ready for the last two problems on part one. Last two problems on part one are to condense. We're going the other direction. Now, condensing has 3 steps. First one is power. Take the negatives. We're going to take the negatives back up as exponents. 2, product. 3 is to simplify. Simplify just means we can't have negative exponents, and if a number would simplify, simplify it. If we have a number to a power and it reduces or simplifies nicely, go on and simplify it. Take the negative with it. So if we look at 36, powers first. So the 6 log of x is going to become log of x to the 6. 5 log of y, we'll take the 5 and put it back as an exponent, giving us a log of y to the 5th. Negative 4 log of 3. Well, we'll take the negative 4 up as an exponent, giving us log of 3 to the negative 4. So when we say take the negative, if there's a negative in front of that log with a number without, we take the negative up. If there's no number, it's just negative 1. Questions on our first step? Well, the next step is our product. If we have 2 or more logs being added together, we can rewrite it as a single log with what's inside being multiplied. Now, I put the number in front just because of our, well, number theory. We put numbers in front of variables. That's the only real reason I did 3 to the negative 4th, x to the 6th, y to the 5th. Now the next step is simplify, yes? Do we have any negative exponents? Yeah, so we need to make it a positive exponent. To do that, we move it from the top of the fraction to the bottom. So our 3 to the 4th would go to the bottom, x to the 6th, y to the 5th. So even if we moved it to the back, it'd still drop to the bottom. Yeah, order doesn't matter because we can multiply any 2 things or 3 things in any order and get the same thing. Okay, questions on this here? 3 to the 4th, is that a nice number? Yeah. If we're not sure, we can grab a calculator, say 3 to the 4th is 81. So we can say log of x to the 6th, y to the 5th over 81. If we have a number to a power and it simplifies nicely, simplify it. 3 to the 4th simplified nicely. 81. If you typed it in and got some long decimal number, no, just leave it as a number to a power. Questions on 36? All right, let's look at 37. Again, first step is our powers. So we'd take the 9/7 and move it back up to an exponent, telling us that we have log base 4 of x to the 9/7 plus log base 4 of y to the 9. Both the logs are being added together, so we can rewrite it as a single log with what's inside being multiplied. Telling us that we have log base 4 of x to the 9/7 times y to the 9th. Both exponents are positive, yes? Even though it's x to the 9/7, that's a variable, not a number. That's as simplified as it gets. Questions on 37 before we look at 38? We go with 37. Natural logs are the same as logs. So again, we'll take the 6 and move it up into the exponent, telling us that we have the natural log of x to the 6. We'll take the negative 4 and move it back up to the exponent, telling us that we have plus the natural log of 2 to the negative 4th. 2 logs being added, telling us that we have the natural log of 2 to the negative 4th, x to the 6th. We do have a negative exponent, yes? Telling us that we have the natural log of x to the 6 over 2 to the 4th. Again, 2 to the 4th does reduce nicely. It is questions on this here? $39, last one. On our property first. We'll move the 2/3 back up to the exponent, telling us that we have the natural log of x to the 2/3 plus the natural log of 27 to the negative 5/3. Two logs being added together can be rewritten as a single log with what's inside being multiplied. Again, I just moved the 27 to the first just because of number theory. I like to put the numbers before the variables, but it doesn't matter. Negative exponents, we're going to have to move them to the bottom of the fraction to make them positive. Positive, I just wrote it negative still. There we go. All right, 27 to the 5/3. Does that look like it'll give us a nice number? No. You know what? Just to make sure, 27 to the 5/3 is 243. Okay. So we can simplify that. So really this is the same as the natural log of x to the 2/3 over 243. So that is everything on part 1. Tomorrow we will go over part 2, the solving and the change of base. Wednesday is part 1, Thursday is part 2. Those of you